Hey guys, welcome to Functional Print Friday. I live out in the country and as such the power is not super reliable out here, so I have a backup generator. And this is my main panel here. And years ago when I put the backup generator in, it essentially backfeeds a breaker here, and what makes this setup safe is I purchased a physical interlock that makes it that this breaker must be turned off to be able to turn the main breaker on. And if we have a power failure, I can turn the main breaker off, slide this over, and then it allows me to turn the breaker that backfeeds this panel from the generator on. Now, this doesn't actually run right to the generator. That runs over to this panel here. This is the panel for the generator. It's just another electrical panel that I reused. And I did this for a couple of reasons. I wanted to have these meters in here to see what the load was. Also have the ability to feed some test outlets even if the output to the main panel was not on, but also to support a second input for another generator. And I am using that now. So this is the input for my main generator. That is a pretty decent sized diesel generator in an outbuilding. But I also have this aux gen input that goes to just a power inlet on the outside of my house that I can connect a portable generator to. In fact, I've got one of those little Honda inverter generators, so that if for some reason I have a problem with the main diesel generator, or I just need to stop that and service it, like change the oil or fuel filter in an extended outage, I can switch over to that power inlet and use a smaller generator to power just essential circuits. The problem here is I have no interlock, so you can imagine a scenario here. There's no power to this panel right now, but so here's, if I flip this on, now I have connected electrically my main diesel generator into this panel, no problem. But if I turn this on as well, okay, well now I've also electrically connected the generator inlet on the outside of my house. Well, there's nothing plugged into it, that's just fine, no problem. But if I had both of these on at the same time with either one of these generators running, it's going to try and energize the alternator on the other generator and cause some pretty significant problems, both from a physical and electrical perspective. I mean, there might be some protection on the input of at least the smaller generator, I'm not sure, but it's going to try and turn the stator on the other generator, and if they're both running and I flip them on, it's going to try and pull them into phase at the same time. Bad things are going to happen, long story short. So I need a similar interlock here as to what I have over here. And this one is just, I think this is laser cut out of some sort of acrylic. And then you can see it slides on these three, I think these are called Chicago screws. And I'd actually have to turn my main breaker off to show you how this slides. But it's just a physical interlock, again, made from acrylic, that prevents me from engaging both of these breakers at the same time. I think I can do the same thing over here. And I'm going to try and do it with a 3D printed part. I don't see why it wouldn't work. I'm thinking PLA should be nice and rigid. In any scenario where there was some sort of fire over here that would cause that to melt, same thing's going to happen to that acrylic. And it's probably the least of my worries if the house is burning down, having a physical interlock here that would prevent me from turning another breaker on. So, but I'm sure if you look down in the comments, somebody will still be calling me a moron. But let's get some measurements on this. I have an idea in my head of how this would work. It just needs to slide vertically up and down and either block this breaker or this breaker. And there is a gap between the two, but I think there should still be enough room to have something that slides. So I'd kind of imagine it's either here in this position and allowing this breaker to be on, or here in this position and allowing this breaker to be on. So let me get you in a tripod. I need to get a bunch of measurements off of this. I'll probably model just the parts of this face that matter, and then design my part against that model. So I'll need, let's see, these breakers are elevated in comparison to this surface a bit. So I'll need the measurement of this, the measurement of these cutouts, where the breaker handles sit when they're both on and off. I think that's about it. So yeah, let me get my caliper, get you in a tripod, and we'll get those measurements. All right, and here is my horrible chicken scratch drawing with the necessary measurements on it, so let's get started. Okay, so the first thing I did was just draw up the important dimensions of the breaker panel itself, and the the major distances that we need. So this is that thin piece of metal that goes down the center that divides the two sides of the breaker cover. This is the height of the, or I should say this face here represents the overall height of the top of the breakers. And then this is the total height of the breaker handles, their length, their distance from each other, and then of course the distance they are from the center in the on position, and this one in the off position. I probably could have done this design without doing this, but I always recommend in a design like this, particularly if something's going to be moving and there's a bunch of parts you need to take into consideration, just take the time to draw very roughly the dimensions of the items that you're trying to design around. And all right, let me go ahead and unhide all the design components. So there is, let's see, there's 1, 2, 3, 4 pieces to this. We have here, I'll just hide the sliding piece so you can see there's basically a spacer piece down here at the bottom that brings this whole thing up to the height of the face of those breakers. And then there are 2, I guess we could call these standoffs here that are going to utilize machine screws going down into them, and then those are going to thread into the actual steel piece that runs down the center here. That'll be drilled and tapped. There's a shoulder in here for that machine screw head to actually sit against, and the idea is that these will tighten down tight against this spacer, and then tightening down the spacer tight against this steel surface here. And then the piece that we're missing that I hid, bring that back, basically just slides freely in these channels here. So there is 0.2 millimeters of clearance between the underside of the standoff and this face here, and then 0.2 millimeters of clearance as well on the sides here for this whole thing to slide back and forth. And you can see, so in this position it allows this breaker to be in the on position, and this breaker is in the off position, and we won't be able to switch this breaker on because this physically blocks it. And then while I can't swap the position of these breakers, if I take this piece, you can see it is going to slide on the, in this case on the green axis, just like this, and it will be limited by the length of those slots. There's 14 millimeters of total motion here, and that should allow 2 millimeters clearance on the breaker handles as their positions are swapped. So, all right, let's print it and see if this is really going to work. All right, and just like that, we have all of our pieces. So I did need to make one design adjustment. When I designed this, I originally had planned on using M3 machine screws, and when I started assembling it, it just seemed like the M3 was just a bit too small. I liked how fine the pitch was on the threads on these, particularly since we don't have that much depth of metal to work with for how this is going to mount. But the M4 just seemed like a much better option, and I think the pitch of the thread on these should still be plenty fine enough for the applications. That means I also ended up with 2 of these because these holes are sized for M3, and I had to print another set of these to be sized for M4 as well. I kept the small one here. I got rid of the ones of these that I had printed for M3 screws, but I kept this because I figured actually this would be useful for, since the holes are smaller, for marking where I need to drill holes in the electrical box, or the cover for the electrical box. And you can see the comparison of these two here. I think this is just more appropriate for this application. So we should be able to basically test assemble this now. So again, we have this shoulder up here that will retain this, and then this surface here is going to slide back and forth on this surface here. So we should be able to drop these guys in. And in fact, I bet you the holes on this are probably tight enough to just tighten these in and try sliding this. Yep, there we go. So you can see now how that is going to, so this is the part I'm moving, is actually, that's the stationary part. Probably makes more sense if I try and hold it like this. And then this is going to move back and forth, or up and down, I should say. Actually, let's go over to the panel and just see what it looks like there. By the way, I have talked about these before, and I'll link them again. Don't order hardware every time you need something. These kits are way cheaper to buy a whole assortment of hardware than it is to just either go out to Lowe's or Home Depot and buy individual pieces of hardware, or to order the particular size you need from Amazon. This kit has everything from M3 by 8 up to M5 by 20, and then has the nuts as well for each. These things are great. I have one of these in the machine screw type, and I've got ones in the round hex head and Phillips head as well. I'll link these down below in the description. Okay, so this is going to go on here. This piece here is going to be centered on this piece of steel here. And actually, I guess to center that, yeah, I could take this off and I'll just measure the distance, tape it in place, and then mark the 2 holes that I have to drill and tap on this steel piece here. But so this will be in roughly this position. Let's see if we go down to the lower position, and we can see we can turn this breaker on now, but not this breaker. That's blocked by this. But if we turn this one off, we can slide this into the uppermost position and turn that breaker on. But now this one is physically blocked. So that should do it for us. Let me get this piece off, taped onto here, centered. Actually, I'm not going to use this piece. I'll use the other piece I made where the holes are a bit smaller. We'll get that taped in place. I'll mark those holes. Then this steel cover is going to have to come off so I can drill those holes and then tap those holes for the M4 machine screws. Okay, I got this piece centered up. I just positioned it roughly where it looked centered, and then measured both sides and adjusted it till it was equal. Taped it in place, and then I just marked through these holes with a marker. So now I have my the 2 locations that I need to drill and tap holes. So I'm going to center punch these, I'm going to drill these, and then I'm going to tap them for an M4 machine screw. All right, very pleased with how those came out. I don't know if you can see those on camera. but those are now drilled and tapped for M4. So let's go ahead and install the actual interlock switch onto that piece. All right, I'm having one small problem here. When I'm tightening these guys down all the way, it's tightening up on this block. It looks like these standoffs should have been just a tiny bit taller to make sure that I am fully clearing this top piece here. So what I mean is I should have made this plastic piece just a little bit taller. Actually, as soon as I pick this up, I can see what's going on. I don't know if I can get you the right camera angle on it, but there's a little bit of a bend in this piece here, and what that's doing is it's causing it to tighten up against that base piece before they get bottomed all the way down. I'm going to see if I can straighten that up a little bit and just get it a little bit looser. But that's what's going on. I can actually see the gap there when I look down across it. I don't know if you guys can see that in the video. Yeah, you can probably see it there. All right, I couldn't capture it while I was bending it, but I've got that center piece straightened out, and now it is. If you look across the back, it sits perfectly flush on there and tightened up. That rides exactly where it should now. There's no play in it, but it moves freely up and down. So, all right, let's go get this on the panel. All right, I put just 2 screws in the panel here to hold the cover in place so we can test this before I tighten everything down. And I can already see it looks like our clearance is good. We probably could have gone a little bit thicker with this spacer plate here. I noticed that this is dragging on the front face of the breaker just a bit. It's just touching it. It's not getting hung up on it. We probably could have come out maybe 2.5 millimeters or 3 millimeters on the thickness of this piece. We have a solid 15 millimeters between this face and the face of the plate. We're well under that. I think this whole stack up is 12 millimeters. So all right, so if we're in the down position, we should be able to turn this breaker on. Yep, no clearance issues. We're well clear. We shouldn't be able to turn this breaker on. Nope, it hits that right away. And if we turn this guy off, this should slide up enough to clear this one. And sure enough, it does. No clearance issues there as well. I had left 2 millimeters gap here and 2 millimeters gap here. It looks like we have about probably a millimeter in actuality here. And this one, yeah, there's probably 3 there. So our alignment either isn't perfect or the breaker handles don't line up perfectly. They have a little bit of movement in there, but that's why you leave yourself a little bit clearance. I don't have to fiddle with this at all. If I just go down position, breaker on, up position, breaker on. This one, this breaker is a little finicky. There's a metal piece here connecting the handles. If you don't click it far enough over for both handles to actuate, it'll click back. But I'm not actually hitting this plate here. It's hitting against the stop on the breaker. You see I actually have a little bit of movement still to go there. I think I'd left 2 millimeters gap there as well. So, all right, very happy with this. I'm going to go ahead and put the other screws in, but I think this is all set to go. I mean, could you override this? I don't think you could override it pushing on this. I don't think you could push hard enough with this breaker handle. Sure, you could come along with a screwdriver and take this off, but that's going to be true with really any physical interlock. The point really is to remind myself while I'm half asleep, firing up the generator, or if somebody else is operating this equipment, to not make the mistake of turning both the aux gen and the main gen on at the same time, and this accomplishes that. We can still have both off for service, and the switch can be in any position, but it has to be in the position that blocks the other handle to actually be able to turn a breaker on. So, guys, thanks for watching. Of course, the STLs are going to be available on fpfdesigns.com for this, for free download, just like any of the designs that I feature on this channel every Friday. Obviously, in this case, they might not be an exact fit for you unless you happen to have the same type of panel, But hopefully seeing this, you should be able to use the same concept to easily make some adjustments either to these STLs or to design your own that would serve the same purpose. I could, in theory, I could probably, if we go back to my main panel here, I could probably redesign that as well in PLA, and it would perform the same function as that acrylic one. The acrylic is probably a bit stiffer than PLA, but you can see in this application, it's not like the flexibility of the material is going to allow us to defeat this interlock. So guys, thanks for tuning in. If this is your first time here, I do a new video like this every single Friday that fixes something I've got around the house or in the shop, or makes something better, or just adds functionality to it. So if you enjoyed this, please hit that like button and consider subscribing. And guys, if you do subscribe, I will see you next Friday.